Hello friends, in this segment we will see how to find z transform of the given signal. Now here x of n is given in the form of a raised to n u of n plus b raised to n u of minus n minus 1. So in the previous lectures we have seen how to find z transform of a raised to n u of n as well as b raised to n u of minus n minus 1. This is a both sided signal. The reason is this is right sided and this is left sided. So first we will directly find the z transform by that relations we have seen. A raised to n u of n will be z upon z minus a. Now coming to the point of region of convergence, it should be drawn with respect to pole point, and here the pole point will be z is equals to a. Now to find z pole point we should equate denominator to 0. That means I can write mod z is equals to mod a. Now this is multiplied with u of n, that means it is a right sided signal, hence its ROC will be greater than mod a. Now next, z transform of b raised to n u minus n minus 1 will be z upon b minus z. Again coming to the point of pole point, we'll equate this to 0, so we'll get z is equals to b, that we can write mod z is equals to mod b. Now this signal is left sided because it is shifted by minus 1 unit, so its ROC will definitely be less than mod b. Remember this thing again, if the signal is right sided or causal, ROC should be greater than pole point. If it is left sided, ROC should be less than pole point. Now I will find its combined z transform, so I will add these terms, z upon z minus a plus z upon b minus z. Now coming to the point of common region of convergence, so here there are two conditions. First, it should be greater than a and it should be less than b. So I can write the combined region of convergence as mod z should be greater than mod a and it should be less than mod b. So this becomes region of convergence of x of z with its z transform. Now we'll try to draw the region of convergence also. So for that case, we'll draw two circles, first for A and another for B. So this is my first circle and these are the pole points as A, and this side it is minus A, and this is our another circle with the pole points B, and then this is minus b. We have considered this as mod z, so it will have two values. Now coming to the point of drawing its region of convergence, we can see the condition is what? Z should be greater than a, that means it should be greater than a, this region will be there. At the same time it should be less than b, that means we can say that the common region of convergence is intersection of these two circles, so that it can satisfy both the conditions as it is greater than a and less than b. So this becomes our ROC, that is greater than mod a and less than mod b. This is real part of z and this is our imaginary part of z. So this becomes finding z transform and mentioning ROC for both sided signals. Now the university exams, they will change only the values of a and b with other terms and remaining terms as it is. So you can draw with respect to that. Now we'll see one more example on this. Xn is equals to 1 by 3 raised to n into u of minus n. Now to find its z transform, I am putting those formula first. Z transform is equals to summation xn into z raised to minus n. That holds n minus 2 plus infinity 1 upon 3 raised to n u of minus n into z raised to minus n. Now this term u of minus n simply indicates that unit step signal is reversed. So we know that u of n will have amplitude 1 for all positive values of n. Now I am reversing this, that means u of minus n becomes amplitude 1 for the values as 0, 1, that is minus 1, minus 2, so on up to minus infinity. And from that I can write this equation as n is equals to minus infinity to 0. In this range, u of minus 1 will have an amplitude as 1. Now we'll rearrange these terms as this is minus infinity to 0. I will try to take n as common from both the terms. So this is 1 by 3 z inverse raised to n. Now to apply the formula, again we'll try to convert these negative values of n into positive values. So this equation holds n plus infinity to 0, 1 by 3 z inverse. Now this plus n becomes minus n. And instead of writing from plus infinity to 0, now we can write this term as 0 to plus infinity. Now this minus n value will assign to both terms. So 1 by 3 inverse becomes 3 and z inverse becomes z. So this becomes 3z raised to n. Now we'll apply the formula. The formula is simple. Summation 0 to infinity a raised to n will be 1 upon 1 minus a. So this equation holds 1 divided by 1 minus 3z, and this is our z transform as x of z. Now if the question is asked, mention its region of convergence. So again we can mention it by considering the pole point. 1 minus 3z is equals to 0. So 1 is equals to 3z and z becomes 1 by 3. Now this signal, if you observe, this is multiplied with u of minus n, that means it is a left sided signal. Hence its ROC should be less than 1 by 3. So this becomes its region of convergence, and this is its z transform. Thank you.